Okay, so we saw characteristic radiation, that's a collision with mostly K shell. Now we'll see what is called as Bremsstrahlung radiation or braking radiation. Okay, again coming back to the same diagram. Again we have supplied a 100 kilovolt potential difference to the cathode and anode, and because of this potential difference there's the electron which is emitting from the cathode to the anode with the energy of 100 kilo electron volts. So let's say that electron is here and this is a tungsten atom which is coming from this target material. So let's say this is the path of that particular electron and there is the nucleus over here. What happens is, as and when it comes closer to the nucleus, it is attracted by the nucleus and hence it changes its path. So because it is attracted towards the nucleus, it changes its path, and because of this there is a decrease in acceleration. There's a decrease in acceleration. Because of the decrease in acceleration, the energy of that particular electron decreases, and the difference in the energy is emitted as an X-ray. So note over here, the energy with which this particular X-ray will be emitted is not fixed, because this depends on where was the electron at the initial place. So how much force is the nucleus by how much force is the nucleus pulling this electron, that will decide the energy of the X-ray that is emitted. So this is not characteristic because this is not dependent on the element, rather this is dependent on the path. So you can, it is possible or it is probable that you get the same X-ray energy with two different elements, and hence this is not characteristic. So you get the difference, why that is called as characteristic radiation and why this is braking radiation, because here in some sense you can, so the analogy is that of a car. So when you are in a car and you are like at an uniform velocity, or you are driving with a certain amount of speed, when you put brakes it will decrease the acceleration, which in turn will decrease the velocity. So because of that brakes, the velocity or the acceleration is decreasing, and that's how this got this name, because it's similar. I mean, there are no brakes as such, but because there is a decrease in acceleration, so just going with the analogy of a car, we can assume that the electrons are putting on brakes. Okay, so this is the other braking radiation. So this is a very important cause of X-ray production. So the X-rays that are emitted from the tube, most of the X-rays come from braking radiation or this particular radiation. And what else? Again, Bremsstrahlung emission is also proportional. So how much X-ray will be emitted is proportional to the atomic number and the mass of the incident particle. In our case, the incident particle is always an electron, so this is kind of constant in our case, but the number of emissions is dependent on atomic number. Again, don't confuse this with the energy. This is not the energy with which the X-ray is emitting. This is the intensity, if you will. It is the amplitude or how much intensity is the X-ray coming out. So the intensity depends on the atomic number for breaking radiation. All okay with this?